Hello and welcome to episode 70 of Daryl Show Your Work. All right, in this episode, I wanted to cover a variety of ways that we can analyze data that goes in and out of our enterprise. So the different things I'm going to cover is doing some manual log analysis through different means, um, using the SEAM tool to do data analysis, and also some webmail analysis. And ultimately, this is to help us to be able to find and remove some threats that may be entering into our enterprise system. So the first thing that I wanted to cover is something called rsyslog. All right. So before I can talk about rsyslog, I first wanted to give a high level definition of what actually syslog is. So syslog employs a client server architecture in order to collect logs from various devices. It's available for all major operating systems and commonly uses the UDP transport protocol for sending log messages. All right. So with that said, now what our syslog is, that is an open source implementation of the syslog protocol for Unix-based systems. So think in terms of Linux and not necessarily Windows. And it's configurable as either a client or a server. It's known for its ease of installation and configuration and offers advanced features such as content-based filtering. So I just want to show exactly what that looks like. And the first thing I'm going to do is I'm going to take us to where the RSys logs are stored within this Ubuntu system here. So I'm going to say sudo cat. So that's going to display what I'm what's going to be in the directory here. So it's located in var log and then syslog. All right, gotta give it my password. All right. So so basically that's what this is. All right. So this is our syslog. So if we take a look at some of the output here, one thing that stands out is this little entry right here, where we have root shell backdoor.shell. Some folks watching this may recognize this from a previous video that I did. And one thing we could also see, okay, if we look over on this line right here, is that it has cron. So meaning that this backdoor shell script is running from a cron job. All right. So if I'm an analyst and I'm looking at the rsys logs, okay, like I'm doing now, and I see something like this, I can simply remove it. Now, as I shown in our previous video, there would be a lot more things that I would need to do. But to immediately to address this, I could just choose to remove it by saying sudo rm. Oops. All right. And that's going to remove that shell script that is associated with that cron job. So it doesn't necessarily get rid of the root issue, because I would then need to find whatever process is triggering this backdoor shell script, and also to then get rid of this cron job. But that's not the purpose of this video, and I've shown myself actually doing those exact steps in a previous video, if you want to check that out whenever you have time. Okay, so the next thing that I want to cover is how can we then use a seam tool to be able to do some analysis to find some threats, and to then eliminate those threats. So I'm going to use the Splunk application, and I've done some similar types of type of log analysis in previous videos as well. But there's also some filters that I didn't use in those videos that I want to display in this one. So first I need to take us to our Splunk instance. All right, and it's located at 172.20. Hold on, I'm gonna put in the address here. There we go. All right, 172.20.1.12. All right, and it's going to be using port 8000. All right, and this is going to take us to my Splunk instance. All right, got to give it my credentials. All right, and then let's see my password. All right, let's try that again. All right, let's try this, because it could be my keyboard acting up on me. Let's just paste you in here. There we go. All right. Okay. Yep, got it. All right. So now that I've logged into Splunk, what I want to do is I want to go to settings up here, and I'm going to choose to add data. All right, now the reason I'm going here is because I'm actually going to be uploading a log file to do some analysis. So I've already have some pre-recorded logs here from a pre that I previously from a previously instance, and I'm just going to upload that into a Splunk here to do some further analysis of that. So I'm going to click upload. All right, select a file, and I'm going to go into my home directory, and it should be access.log. All right, hit next. All right, so source type, all right, that's already where it should be. I'm gonna hit next. Reviewing everything looks good. All right, and let's submit it, and that should take me into it. Okay, then I'm gonna hit start searching. All right, I'm gonna skip that. All right, the first thing that boy, it's a lot of pop-ups. All right. The first thing that I want to do here is I want to go over to the, next to events. I want to go to patterns. All right. So if we look at these two lines right here, we can see it appears that the most requests are directed at /WP dash login, and a user agent is WPScan. All right. So this is a strong indication of a potential brute force. All right, because this is a WordPress scanner, and the fact that it has so many instances, it's finding you know uh, uh, 5,776 related events of this consistent WordPress scanner running against this WP login, meaning that it's trying to log in multiple times with this with this WordPress scanner against which I suspect would be a a web server that's indicative of a brute force attack. All right. So then if I wanted to, let's say I wanted to dive a little deeper into this, what I could do is I can add some extra search criteria here. All right, so I'm going to add, let's see, say pipe, and then let's say stats count by user agent. We want to sort this. Oops. Dash count. Okay. All right. So after doing this, so it looks like we have 13,435 events that were generated by the WPScan user agent. All right, so that breaks down exactly how many specific instances that we have where WP scan was the user agent. All right, so that's what that tells a stat. So let's say we wanted to extract information about the client IP address that sent these requests. All right, so let's say we wanted to see again that the IP address status where this is coming from, or where this WP scan is being used as the user agent. So I'm gonna modify this line a little bit. All right, so stats by client IP. Sort count, and I'm gonna say client IP. All right. Make sure everything is all right with my syntax there. All right. So so by looking at this, all right, so the stats keyword shows, all right, right here, the stats keyword shows statistics such as the average, count, and sum. Where the sort count displays the results based on which client IP addresses generated more logs. Okay, so that's basically what we're looking at here by using this filter right here. All right. So the next thing I want to do is let's filter the logs based on the the user agent file to see which IP address is associated with the WP user agent. And I misspoke when I when I said that this is the one that was supposed to show that. This is the one that's going to show us that information. So please excuse my error there. So let's see. Get rid of all of this, and I'm going to say user agent equals, right, we said WP scan. Well, no, we want to do a wildcard there for every instance. All right, and then pipe stats by client IP. All right, so this should tell us who the offender is, as far as that's associated with the WP scan. All right, so I'm gonna hit enter. All right, so it looks like our perpetrator is at 172.20.0.9. All right, so those are a few filters that we could use within Splunk to be able to give us specific information about instances, and we want to narrow down well, first to be able to tell us how many instances of a particular um, user agent or event is happening for us to be able to deduce if we suspect there's some type of attack like a brute force. Okay, and then we want to dig a little deeper and see, well, is this all coming from a single place? All right. So this shows us that it is, and we're able then to see which IP this is coming from. And if this is someone that's actively on our network, we can then isolate that machine from our network and remove access from that particular machine that's located at that IP address and do some further investigation from there. All right. So that's basically using SIM rules to do some analysis. All right. So the next thing I want to do is I want to do some webmail analysis. All right. So to get started on that, I'm going to take us to our webmail client, and that is at http slash slash 172.20.1, and it's at the same place, but it is using a different port. So this is actually at 8025. All right, so this is going to take us to our webmail client. All right. So I'm right now I'm looking at my webmail mailbox here. All right. So if this was some sort of attack scenario, all right, and I was got some information that, hey, one or a few of these emails are malicious. So if I want to start my investigation here, I'm going to start with this second email here, and I'm going to say I'm going to go to this one that says you're doing amazing. All right, so I see that there's a hyperlink here. So if I wanted to check to see if this hyperlink is legit, I could go over to the upper right hand corner and click Show Headers. All right, so the two areas that I'm looking at is with the from is the email that's behind the where it says labs. I can see that it comes from an infosecinstitute.com, and then I can also see that the return path is the same. So well, except this one says labs with an S. But because they both are using this same extension, this is a legit extension, okay, and this is also an extension that reflects my extension, then this tells me that this is a legitimate email. So my investigation continues. All right. So let's say if I wanted to go to your next challenge. All right. So I'm going to do the same thing that I did before here, and I'm going to go to show headers. All right. So there's a major difference here. So number one, we can see admin, and infosec is missing an I. Okay. And then if we go to return path, we can see that that is actually from attacker at malicious.com. So this tells us that, that more than likely that this is, if we were to click this link, it would do something malicious, probably some type of drive-by download, or it could be some sort of phishing attempt, et cetera, et cetera. So to further investigate this, I'm actually going to download this email to my system. So I'm click download. All right. And then I'm gonna go back to my terminal. All right. So to begin analysis on the email and its contents, first I need to switch to my downloads directory, because that's where that email was downloaded to. All right. Give me a minute here. All right. And now that we're in there, I'm gonna do a list command just to verify that our email is in there. And that is our email. So let me copy this, because I'm going to need to use this email name, because my next steps is, just for some ease, I'm going to rename this email to something far more simpler. All right. So in order to do that, I am going to say MV and then paste the that suspected phishing email's name here. And then next to it, I'm going to write what I want to name it to. And let's say I'm going to simply name this to, let's say just phishing dot EML. All right. So that way it's much more simpler. All right. And then list to make sure that, okay. So, all right. So that's how we then, once we, that's, so what I'm showing here, this is how when we find a suspected phishing email, and if we're working as a analyst, as a cybersecurity analyst, we then download that file to our local directory, and then we can rename it, since sometimes that the email name would be something very complex, and this is just how we rename it, and we would save it here just for further analysis, or to send this to the next our next tier, to for further review. All right. So the next thing I wanted to that I did want to cover is being able to identify malicious payloads in the actual webmail. So I'm gonna go back to our webmail client. All right, and then let me go back. All right, so the next email that I want to look into is malicious payloads. All right, so I'm from here. I'm going to actually click on the link here. All right, so that takes me to this page. So there's something I want you to pay close attention to when I click this this document, this .png document, okay? Because there's something that's going to change. So when I click it, it should automatically download. Here on our right, do you see how over here that this file name is a .png file, but over here is in gnp.elf. All right. So just explain what's going on there. The underscore GNP is an Unicode character used for right to left overriding of text, meaning all the text after this character will be shown in reverse. The character does not get interpreted in our target machine. So for this reason, when the file gets downloaded, its original file name is shown, which is the underscore gnp dot elf. All right, so the browser, however, interprets the Unicode character and reverses the text after it, meaning that gnp.elf substring located after gets shown as lfe png. All right, and so in this way, the user gets tricked into thinking they are downloading a .png file. All right, so that's what's going on here, and we can see that where it says ELF right here, that's what's going on. All right, and we can't necessarily see the underscore there, but it's just a clever trick for an attacker basically to use Unicode to reverse the format of a file into looking as something legit, as a PNG image file. All right, so what I want to be able to do here is I want to download. So we have this to download into our file. So I want to be able to do some further analysis with that tool called Binwalk. So going back to my terminal, first let's make sure that that is indeed in our local directory by doing the list command. All right, so we can see that indeed that gnp .elf document is in there. All right, so again, I'm going to use a utility called Binwalk to inspect the file. All right, And to give a high level overview of what Binwalk is, it's just a command line tool that inspects files for embedded code. And so basically by inspecting for embedded code, it's going to be able to tell us if there's anything executable in that file. All right. So in order to do that, first I'm going to copy this file name because I don't want to have to just write all of that out. All right. So I'm going to say Binwalk, and then I'm going to paste the file name here that we're working with that we wanted to analyze. All right. Let me say, give it a greater than sign. And basically by doing that, I'm going to tell, hey, Binwalk, analyze this file. And then after you analyze it, output it to a new file called Binwalk output.txt. All right, so it's going to, again, it's going to inspect the file, and it's going to then, whatever its findings are, it's going to put it into this binwalk underscore output.txt file for us. All right. All right, so I am going to use, instead of just using the cat, I'm gonna explain why I'm doing this after I do it. I'm gonna use actually the head command to display the output in the output file here. And for those that don't know, the head command within Linux, it basically shows us the first 10 lines of a document that we're specifying. And here I want us to show us the first 10 lines of binwalk underscore output. All right, so it gives us those requested lines. So basically, basically the best way that I can interpret what's going on here, that Binwalk is indeed confirming that there's some executables masked as the .png file in this gnp .elf file. Okay, so it has executables in it, and whether the executables are malicious or not will require more analysis, but we don't want random executable files sent to our webmail or enterprise. And to show you why it is that I did a head command instead of the cat command to display it, I'll just bring this back up. And another reason why it's suspected that this file is no good. Look at all of this data. So instead of trying to, you know, it's just a ton of information here. All right. So that's why I just wanted to give us a more condensed view of what's going on instead of trying to view everything in the file and trying to, trying to explain, what all of it means when it's pretty redundant as far as what it's coming back with. All right. So that brings me to the end of the video here. So to give a high level overview of what was done. So I just wanted to give some various ways in which we can conduct analysis to find and remove threats. So first I went over syslog and rsyslog and where we could find those rsyslog entries and how we can look through those rsyslog entries to find and eliminate a malicious threat. And then I went into using the Splunk sim to show. I used I uploaded a log instance, and from there I showed how we could use different sort of filters to zero in on specific details in order to be able to root out things such as the IP address of our attacker, and be able to see by what means did they be able to first identify the attack and then see by what means did this attacker use in order to carry out their attack. And then I went into our webmail client and gave some examples of what a legitimate email looked like as far as headers, and then showed what a potentially malicious instance looks like when looking at those same headers, and then how we can then download that instance, rename it, and use it later for further analysis, and then also how we can then um, do some malware analysis by paying attention to changes in extension when we download certain malicious files, and then how we can use a tool such as Binwalk to be able to identify any sort of executable elements within that file, and again store that and send it to the necessary people for further analysis and potential reverse engineering. So please like, subscribe, and share. And most importantly, show your work. And until next time, take care of yourself and God bless.